Good morning, students. Welcome to Bindu Dhadwal Chemistry Lessons. Our topic for today is Diazonium salts. Diazonium salts were discovered by John Peter Grace in 1858. The general formula is arene N2 positive, X negative, where X negative is an anion like Cl negative, Br negative, HSO4 negative, BF4 negative, etc. The group N2 positive is called Diazonium group, and these diazonium salts are obtained when aromatic primary amines react with nitrous acid in cold conditions. Nomenclature of diazonium salts: we use the suffix diazonium to the parent aromatic compound followed by the anion name. So this is benzene diazonium chloride. This is meta position, so meta hydroxy benzene diazonium bromide. This is para methyl or para-toluene diazonium hydrogen sulfate or para-methyl benzene diazonium hydrogen sulfate. This is para-nitrobenzene diazonium fluoroborate. Preparation of diazonium salts. Aromatic diazonium salts are prepared on treating in ice-cold solution of aromatic primary amines in excess of mineral acid like HCl or sulfuric acid with an ice-cold solution of sodium nitrite dissolved in water. Temperature 273 to 278 Kelvin. NaNO2 plus HCl will form NaCl plus HONO. Aniline on reaction with NaNO2 in presence of HCl will form at 273 Kelvin arene diazonium chloride. Along with it, NaCl and water will be formed. Since the diazonium salts are unstable and explosive substances, they are not isolated in solid form but are used directly in the solution. So aniline plus NaNO2 plus 2HCl at 273 Kelvin forms diazonium chloride, NaCl and water. Stability. Aromatic diazonium salts are stable due to dispersal of positive charge on the benzene ring. These nitrogen will take the electrons and these electrons move here, resulting in a positive charge. These electrons move here, resulting in a positive charge here. These electrons move to result in a positive charge here. And in the last structure, electrons come back to form this structure. So, because the positive charge disperses towards benzene ring, they are stable. In comparison, these are aromatic. In comparison, primary aliphatic diazonium salts are unstable and will decompose to give alkyl cation, nitrogen and halide anion. At higher temperature, even aromatic compounds will form different products. Aniline with the nitrous acid at temperature greater than 278 Kelvin will form phenol and nitrogen and water. Physical properties of diazonium salts: they are colorless crystalline solids, readily soluble in water and stable in cold but react with water when warmed. They are less soluble in alcohol. They are unstable and explode in dry state, so they are generally used in the solution state. Certain diazonium salts such as fluoroborate are water insoluble and are stable enough to be dried and stored. Their aqueous solutions are neutral to litmus and conduct electricity due to presence of ions. Chemical properties can be divided into two categories: reactions involving displacement of a diazonium group with some group and reaction involving retention of diazo group. First is replacement. Replacement by hydroxy group. When diazonium chloride, aryl diazonium chloride, is warmed with water, phenol is formed along with nitrogen and HCl. Replacement by hydrogen or deamination group. Diazonium chloride, when reduced with hypophosphorus acid and water, gets reduced to benzene hypophosphorus acid gets oxidized to phosphorus acid, and nitrogen and HCl are also formed. It can also be reduced with ethanol. When heated with ethanol, it forms benzene, and ethanol gets oxidized to aldehyde. Replacement by chloro and bromo group. When benzene diazonium chloride is reacted with cuprous chloride and HCl, chlorobenzene is formed. This reaction is called Sandmeyer reaction. Similarly, bromobenzene can also be formed. But instead of cuprous bromide, if copper powder is used along with HCl, the chlorobenzene is formed and reaction is called Gattermann reaction. Similarly, bromobenzene can also be formed. When benzene diazonium chloride is heated with potassium iodide in excess, iodobenzene is formed along with nitrogen and KCl. To replace fluoro group, we treat benzene diazonium chloride with fluoroboric acid. Benzene diazonium fluoroborate is formed. On heating, it decomposes to give fluorobenzene and BF3. If we react benzene diazonium chloride with copper cyanide and potassium cyanide, we get cyanobenzene and nitrogen. These can be hydrolyzed into respective carboxylic acids. So on hydrolysis, cyanobenzene will give benzoic acid. Benzene diazonium chloride on treatment with fluoroboric acid will form benzene diazonium fluoroborate, which on reaction with sodium nitrite in presence of copper on heating to form nitrobenzene and sodium fluoroborate and nitrogen. Similarly, benzene diazonium chloride, if heated in presence of cuprous oxide with nitrous acid, can form nitrobenzene. Replacement by thiol group, SH group. So benzene diazonium chloride on treating with potassium hydrosulfide will form thiophenol and nitrogen and KCl. Reactions involving retention of diazo group. Coupling reaction. Benzene diazonium salts react with highly reactive electron-rich aromatic compounds such as phenols and amines to form azo compounds such as diazobenzene. The reaction is known as coupling reaction. The azobenzenes are generally colored and are used in dyes. The color of azo compounds is due to extended conjugated system with the two benzenes involving the double bond of aromatic rings through the nitrogen-nitrogen double bond. So diazonium chloride, when reacts with electron-rich compound like phenol or aniline, the para position of hydrogen will react with Cl to form HCl, and these two combine from the site to form para-hydroxyazobenzene or para-amino-azobenzene. This phenol is acidic. This reaction takes place in basic medium, pH 9 to 10, whereas this is basic. This reaction takes place in acidic medium, pH 4 to 5, at a temperature of 273 to 278 Kelvin. Phenol will form an orange dye, aniline will form a yellow dye. Coupling occurs para to hydroxy or amino group. If para position is blocked, then ortho position will result. In case of aromatic compounds containing both OH and NH2 group, coupling will occur in alkaline medium, para to hydroxy group, in acidic medium, para to amino group. For example, at a basic medium, it will occur ortho to hydroxy group, and in acidic medium it will occur ortho to amino group because para position is blocked. We can also reduce benzene diazonium chloride with SnCl2 and HCl in presence of Na2SO or in presence of sodium sulfide to form arene hydrazine, or if vigorous reducing agent is used like zinc, HCl. The product is aromatic amine aniline. So that's all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.